In this lesson, we want to talk about solving absolute value equations with quadratic and rational expressions. All right, so previously in our course, we talked about how to solve kind of simple absolute value equations where basically we were only dealing with linear equations, okay? So we're going to go a little bit deeper into this topic, and we're going to look at some additional examples that are slightly more challenging. You might say not more challenging, but more tedious, because we're going to involve some quadratic expressions and some rational expressions. So we'll end up having to solve some quadratic equations and also some rational equations, okay? So we're going to boil this down to a little rule. If u is an algebraic expression and a is some positive number, so it's greater than 0, so it's not 0 and it's not negative, right? Because 0 and negative would each give us a special case. We'll talk about that in a second. So the absolute value of this algebraic expression u, if that's set equal to this positive number a, then what we get is that the algebraic expression u could be equal to the positive number a, or the algebraic expression u could be set equal to the negative of that number a, okay? So as a quick example, this is something we already know how to do. Let's say we have the absolute value of 2x minus 5, and this is equal to 3. The first thing is notice how the absolute value operation is isolated on one side, and you have a positive number on the other. Okay, so that's always what we want to set up. So then we can use our little rule. Again, it's kind of cut off the screen here, but if the absolute value of some algebraic expression u is equal to some positive number a, then u is equal to a, or u is equal to negative a. We're just going to use that here. Again, this expression here, 2x minus 5, that's u, that's the algebraic expression. And then 3 is the positive number, that's a. So I would say that 2x minus 5 could be equal to 3, or 2x minus 5 could be equal to negative 3. Now, what we're basically saying is that this guy right here could be set equal to 3, right? If I get a value for x that gives me a result of 3, I take the absolute value of that, I get 3. Also, this guy right here could be set equal to negative 3, because if this guy in here evaluates to negative 3, well, when I take the absolute value of negative 3, I also get 3, okay? So that's why this ends up working itself out. So let's just solve this real quick. I'm going to add 5 to both sides of the equation. I'm going to get that 2x is equal to 8. Divide both sides by 2. I'm going to get that x is equal to 4. Over here, I'm going to add 5 to both sides. I'm going to get that 2x is equal to negative 3 plus 5 is 2. Divide both sides by 2. I'm going to get that x is equal to 1. Okay, so we get x equals 4 or x equals 1. Now you can easily check that. You could plug in a 4 for x there. And basically 2 times 4 is 8. 8 minus 5 is going to be 3, right? So you know with the absolute value of 3, which is 3, so that works itself out. Okay. The other scenario is going to give you the absolute value of negative 3, because that's also going to give you 3, right? If I plug in a 1 for x, 2 times 1 is 2. 2 minus 5 is negative 3. Again, the absolute value of negative 3 is also 3, so this works as well. All right, so before we go any further, we have to understand the special cases that we might run across. And we covered these earlier in the kind of course when we talked about absolute value equations, but we need to kind of jog your memory so that you are ready for all the scenarios you're given. So let's say you have the absolute value of 4x minus 5, and this is equal to 0. Well, what happens is if this guy is isolated and it's set equal to 0, well, think about the fact that 0 is 0 units away from itself on the number line, right? So the only number that's going to have an absolute value of 0 is 0, okay? So you're not going to have a compound equation with or here. You just have to set 4x minus 5, this expression, equal to 0, and then just solve, okay? So this is a little bit easier, a little less tedious. So to get our solution there, we just add 5 to both sides of the equation, and we'll get that 4x is equal to 5. And let's divide both sides of the equation by 4. And we'll find that x is equal to 5/4, okay? And obviously, if you check that, if you plugged in a 5/4 there, 4 times 5/4, the 4s would cancel. You just have a 5. 5 minus 5 is 0. The absolute value of 0 is 0, so that checks itself out as well. All right, last special case scenario is if the absolute value operation is isolated and it's equal to some negative value, there's no solution, okay? And the reason for that is the absolute value operation takes a negative and makes it positive, takes 0 and spits out 0, takes a positive and spits out the positive, okay? So you can't plug in anything for x here and then multiply it by 6. That guy, subtract away 2, right? Take the absolute value and end up with a negative 12, right? Because the absolute value operation is going to kind of stop all that because it will never, ever be equal to some negative value. So you can't get a negative 12 as an answer for that. So this guy right here is no solution, okay? It's no solution. We can use our symbol for the null or empty set. All right, so now let's jump in and look at some problems where we have some quadratic expressions involved. So suppose we had the absolute value of x squared minus 5x, and this is set equal to 6. So we have exactly what we talked about earlier. If we had the absolute value of some expression u, and it's set equal to some positive number a, well then u could be a, or u could be the negative of a, okay? So it's the same concept, we're just using kind of more complex expressions. So we would have x squared minus 5x, x squared minus 5x. We'd set that equal to 6. Then or we'd have x squared minus 5x would be equal to negative 6, okay? All I did was follow this. This expression is my u. This guy right here, this number is my a, okay? So I'm just following that just like we saw, okay? So now I can solve each of these. They're kind of easy quadratic equations to solve because they're both factorable. I can subtract 6 away from each side of the equation here. I would have that x squared minus 5x minus 6 equals 0. And I'll go ahead and solve this real quick. So as I alluded to, this can be factored. The left side here, if I think about two integers whose sum is negative 5 and whose product is negative 6, well, you think about negative 6 and positive 1, right? Negative 6 and positive 1. Because negative 6 times positive 1 would give you negative 6. Negative 6 plus 1 would give you negative 5. So this is our factorization here. Then we would set each factor here equal to 0. So x minus 6 would be equal to 0. And then we'd also have x plus 1 equal to 0. And let's go ahead and solve that. So we would add 6 to both sides of the equation here. X is equal to 6. Over here, I'd subtract 1 away from each side of the equation. So x is equal to negative 1. So the two solutions here are that x equals 6 or x can be negative 1. So let me kind of copy this because this is going to get a little bit too busy. And let me kind of come back up here for a second. And I'm just going to erase this. We already know the rule. And I'll just kind of paste this in here. So those are two solutions. I'm going to go ahead and get rid of this whole branch. We don't need it anymore. All right, so for this one, it's another easy one we can solve with factoring. So we have x squared minus 5x. I'm going to add 6 to both sides. So plus 6 equals 0. So I'm going to factor this guy. So this is x and this is x. Give me two integers whose sum is negative 5 and whose product is positive 6. Well, that would be negative 2 and negative 3, right? Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. So we're good to go there. All right, so what we want to do is just set each factor equal to 0. So x minus 2 equals 0, and then x minus 3 equals 0. Add 2 to both sides of the equation here. You're going to get that x is equal to 2. Add 3 to both sides of the equation here. You'll get that x is equal to 3. Okay, so x equals 2 or 3. Those are another two solutions. So let's just write those in right here. Let me erase all this. So let's pop those in here. So 2 and then 3. So a little bit more tedious, and you actually have more solutions here. You have 4 solutions, whereas the problems we looked at before, in most cases, you had 2 solutions, right? And you can go through and plug all these in and verify they work. And just for this one, we can go ahead and check it just to see what happens. For the rest of them, I'm not going to check it just in the interest of time, but I just want to show you that you're going to have 2 of these that are going to evaluate here to be the absolute value of 6, so that's going to work out. Then the other 2 are going to evaluate to be the absolute value of negative 6, so those are going to work out as well, right? Because in each case, the absolute value of 6 or the absolute value of negative 6, it produces 6, so the left and the right side will be equal, okay? So for this scenario, 6 squared is 36, so you'd have 36 minus 5 times 6, which is 30. 36 minus 30 is 6, so it's this scenario here. So this one works. Then for this one here, negative 1 squared is 1. Then you have negative 5 times negative 1, which is positive 5. So you sum those and you get 6. So again, this scenario here, so that one would work. Then for these two, you're going to end up with negative 6, right? So 2 squared is 4 minus, you have 5 times 2, which is 10. 4 minus 10 is negative 6, so that's this scenario here, so that works. Then the other one, plug in a 3. 3 squared is 9. Minus, you have 5 times 3, which is 15. 9 minus 15 is also negative 6. So this guy is going to work as well, right? So in this scenario, again, we want the inside of this guy right here. We want that expression to evaluate to either 6, right? That's this scenario here. Or negative 6, that's this scenario here. either way, we'd end up with an answer of 6. So 6 equals 6. So our solutions here are correct. All right, let's take a look at one that's a little bit more challenging. It's just more tedious. We have 4 times the absolute value of x squared minus 3x plus 7 equals 47. Okay, so in this particular case, our absolute value operation is not isolated. Okay, we know from earlier in the course that we've got to have it isolated. We can't just start doing stuff. I see a lot of students when they get this, they go, okay, well, this is 4 times the absolute value of x squared minus 3x, plus 7 equals 47. And then they do this again and they say, okay, 4 times the absolute value of x squared minus 3x plus 7 equals negative 47. No. Remember, your rule is that the absolute value of u, okay, this is isolated. If that's equal to a, then u equals a, or u equals the negative of a, okay? But this has to be isolated. Notice how there's nothing else besides that absolute value of u. So if it's not isolated, you've got to do a little bit of work to kind of get things set up, get things started first, okay? So let's go ahead and subtract 7 away from each side of the equation. We'd have 4 times the absolute value of x squared minus 3x. And then this is equal to 40. Now I can divide both sides of the equation by 4, right? Because that's what's multiplying this guy. So this cancels. You'll have the absolute value of x squared minus 3x is equal to 10. Okay, so this is something we can deal with. This is something that matches this format here. Again, just a little bit of extra work, but not too bad overall. Okay, so let's go ahead and set up our two cases. So the first case is that x squared minus 3x, this algebraic expression, is equal to 10. Okay, then or the second case is that x squared minus 3x is equal to the negative of 10, or just say negative 10. And now I'm just going to solve these two equations. So let's kind of scroll down, get some room going. This guy right here, I'll subtract away 10 from each side of the equation. I'm going to have that x squared minus 3x minus 10 is equal to 0. And I can solve this guy with factoring. So the left side of this guy, I can set this up as x here and x here. Give me two integers that sum to negative 3 and then have a product of negative 10. That's going to be negative 5 and positive 2, right? Negative 5 times positive 2 would give me negative 10. Negative 5 plus 2 would give me a negative 3. So let's set each factor equal to 0. So I'll say x minus 5 equals 0. Add 5 to each side of the equation. I get x is equal to 5. Then over here, I would say x plus 2 is equal to 0. Subtract 2 away from each side of the equation. I get x is equal to negative 2. So those are two solutions. We got x equals 5 and x equals negative 2. So let me erase this part. We don't need it anymore because we already have the solutions. I'm just going to erase this, and I'm going to go back to the top and just kind of write my answers up there because the screen's just going to get a little too full. Okay, so I'm just going to write that x is equal to, again, we have 5 and then negative 2. Okay, so let me go down, and now we're just going to solve this equation here. Okay, so we have x squared minus 3x. I'm going to add 10 to both sides of the equation. So plus 10, this equals 0. So unfortunately, this guy is not going to be factorable. This is something we need to use our quadratic formula to get a solution for. So with our quadratic formula, we're going to label this as a, right? We have a 1, an understood coefficient there for x squared. We're going to label this negative 3 as b. And we're going to label this 10, this constant as c. So the quadratic formula, if you will recall, x is equal to the negative of b plus or minus the square root of, you've got your b squared minus your 4ac all over 2a. So what is b? Again, that's negative 3. So the negative of negative 3 is 3. Then negative 3 squared would be 9. Then minus 4 times a is 1. So negative 4 times 1 is just negative 4. Then times 10, which is c. Negative 4 times 10 is negative 40. So you would have 9 minus 40. 9 minus 40 is going to be negative 31. So this is negative 31 here. And then a again is 1, so this is just 2. Okay? So x equals 3 plus or minus the square root of negative 31 over 2. We can clean this up by using our imaginary unit. So we'll say x is equal to 3 plus or minus, I'm going to pull the negative out as I, times the square root of 31. Again, this is over 2. Okay, so again, this is two solutions. It's 3 plus I times square root of 31 over 2, and it's 3 minus I times square root of 31 over 2. Okay, so let me copy this, and I'm going to erase everything else. Okay, so I'll put comma and I'll put this here. So we have 4 solutions. X can be 5, X can be -2, X can be 3 plus I times square root of 31 over 2, and then lastly, X can be 3 minus I times square root of 31 over 2. All right, let's move on and look at one with a rational expression involved. So here we have 7 times the absolute value of, we have 5x plus 1 over x minus 2, then plus 9, this equals 30. So again, it's the same thing. What we want to do is isolate this absolute value operation, because again, I'm just going to write this rule. The absolute value of u, this algebraic expression u, which is this in this case, if that's equal to some positive number a, then u equals a or u equals negative a, okay? So what can we do? Let's just subtract 9 away from each side of the equation. We're going to have that 7 times the absolute value of 5x plus 1 over x minus 2 is equal to 30 minus 9 is going to be 21, okay? So 7's multiplying this absolute value operation. So let's divide both sides by 7, and that's going to get us to what? This cancels at the absolute value of 5x plus 1 over x minus 2, and this is equal to 21 over 7 is 3, okay? So at this point, again, I have an absolute value operation that's isolated on one side. I've got a positive number on the other. So I can go ahead and just use my rule. And what I'm going to say is that I have 5x plus 1 over x minus 2. That's set equal to 3. Then or we have 5x plus 1 over x minus 2. That's equal to -3, okay? So pretty easy to solve these. In each case here, it's going to be quickest to just cross multiply. So I'm going to just write this as 3 over 1. I'm going to write this as -3 over 1. So x minus 2 times 3 would be 3 times the quantity x minus 2. And then 1 times 5x plus 1 is just 5x plus 1, okay? So if I go through, use my distributive property, this would be 3x minus 6 is equal to 5x plus 1. All right, so to solve this, we can just subtract 5x away from each side of the equation and then add 6 to each side of the equation. So we know this cancels and this cancels. 3x minus 5x is -2x. And this is equal to 1 plus 6, which is 7. Divide both sides by -2. And we're going to end up with x is equal to -7 halves. Okay, so that's one solution. Let me kind of erase this because the screen gets just too packed. And I'll just say that x is equal to -7 halves. Okay, that's one solution. We're going to have another. So let's go back down. So now let's work on this one. Again, I'm just going to cross multiply. So I would have -3 times the quantity x minus 2. This is equal to 1 times the quantity 5x plus 1, which is just 5x plus 1. Okay, so -3 times x is -3x. -3 times -2 is plus 6. This equals 5x plus 1. So to solve this, let me subtract 5x away from each side of the equation and subtract 6 away from each side of the equation. So we're going to see that this is going to cancel and this is going to cancel. So -3x minus 5x is -8x. And this equals 1 minus 6 is going to be -5. Let's divide both sides by -8. And we're going to end up with x is equal to 5/8. Okay, so 5/8 is a solution and -7 halves is a solution. So let's go back up and just list 5/8 as another solution. Okay, so this guy, again, x equals -7 halves and x equals 5/8. Again, you can check it. I'm not going to in the interest of time, but you'll see that each one of these does give you a true statement when you plug it in for each occurrence of x. All right, so additionally, we might see some problems where we have two absolute value operations set equal to each other. We talked about these earlier when we looked at absolute value equations in our course. And again, for this, basically what you have is you have to think about the fact that two numbers can only have the same absolute value if they're the same number, meaning they're equal to each other, or if they're opposites. So for this scenario, you're going to set up another compound equation with or. For the first case, you're just going to drop the absolute value bars. So for the first case, I'm just going to say that x squared minus 1 is equal to 2x minus 1. Okay. Then for the second case, I'm going to drop the absolute value bars. So I'm going to say x squared minus 1 is equal to 2x minus 1. But what I'm going to do is I'm going to make one of the expressions into its opposite. Okay, so the way to do this is just to wrap the expression inside of parentheses and just put a negative in front. So you can do this one or you can do this one, but don't do both, right? If you did both, then you're basically just going back to this because I can divide both sides by -1, okay? So make sure you just do one of those, okay? So I'm going to solve this one first, and let me put my or kind of in the middle here. And I'll just drag this down so I have enough room to work. And so let me start by kind of moving everything to the left side. So let me subtract 2x away, and let me add 1 to both sides. So this is going to be 0 over here on the right. So what we're going to have is that x squared minus 2x, -1 plus 1 is 0. So this is just equal to 0 over here, okay? So x squared minus 2x equals 0. I can quickly solve that with factoring. Pull an x out, you'd have x minus 2. So basically x could be what? It could be 0 or it could be 2, right? So x could be equal to 0, and I found that by just setting x equal to 0. Or x could be 2. I found that by saying x minus 2. This factor here, set that equal to 0, x would be 2. Okay, so those are the two solutions from there. So x equals 0 or 2. Okay, let's look at the other kind of equation that's involved here. So I'd have x squared minus 1 is equal to, I got to make that a little better. You have this negative that's got to get distributed, so it would be -2x and then plus 1. Okay, so again, move everything over. So you're going to have x squared, add 2x to both sides of the equation. So plus 2x, subtract 1 away from each side of the equation. So over here, again, this is 0, and then -1 minus 1 is -2. This equals 0. So can we solve this with factoring? No, this guy isn't going to be factorable. So let's go ahead and set up our quadratic formula. So let me erase this so we have a little room to work. And we already know that this has an implied coefficient of 1. So that's my A, this is my B, and this -2 here is the C. So x equals what? It's -b, b is 2, so -2, plus or minus the square root of b squared. Again, b is 2, 2 squared is 4, minus 4 times a is 1, times c is -2. So -4 times -2 is +8, 8 times 1 is still 8, so you would have 4 plus 8, which is 12. Okay, so this would be 12 here. This is over, 2 times a is 1, so just 2. Okay, so square root of 12, I know that 12 is 4 times 3, so let's write this as 4 times 3. We know the square root of 4 is 2, so I can pull this out and say this is 2 times square root of 3. Okay, so let me erase this. Now, we know we can simplify this a little bit. So to make this simpler, let me factor out a 2 from the numerator. That will give me a -1 plus or minus a 1 times square root of 3. And this is over 2. And we can see that this would cancel with this. And so what I'm left with, I can just erase this. I don't need a fraction anymore. I basically have -1 plus or minus the square root of 3. Okay, so my other two solutions would be -1 plus or minus the square root of 3. So those are my 4 solutions. X could be 0, x could be 2, x could be -1 plus square root of 3, or x could be -1 minus the square root of 3. All right, let's take a look at one more example of these, and this is with rational expressions. So the absolute value of 3 over x minus 1 is equal to the absolute value of 4 over x plus 2. So for this, again, the first scenario, just drop the absolute value bars. They could just be equal. So 3 over x minus 1 is equal to 4 over x plus 2. Then or, for the second scenario, drop the absolute value bars. So 3 over x minus 1 is equal to 4 over x plus 2. And then make one of the expressions into its opposite. So for this guy, all I need to do is make one of the numerators negative. So I can just say this is negative, or I can say this is negative, but just don't do both of them. Okay, so let me just solve this one first. I'm going to cross multiply. So you'd have 4 times the quantity x minus 1 is equal to 3 times the quantity x plus 2. Let's kind of scroll down and solve this. So you'd have 4x minus 4 is equal to 3x plus 6. So now let me subtract 3x away from each side of the equation. Let me add 4 to both sides of the equation. And this guy is going to cancel. This guy is going to cancel. 4x minus 3x is x. 6 plus 4 is 10. So one solution is that x is equal to 10. Then over here, let me cross multiply. So you'd have what? You'd have that -3 times the quantity x plus 2 is equal to 4 times the quantity x minus 1. -3 times x is -3x. -3 times 2 is -6. This equals 4 times x, which is 4x. And then 4 times -1 is -4. Okay, so let me add 6 to both sides of the equation. Let me subtract 4x away from both sides of the equation. So this is going to cancel, and this is going to cancel. You have negative 3x minus 4x, which is negative 7x. And this equals negative 4 plus 6, which is going to be 2. We can finish this up by just dividing both sides by negative 7. We're going to find that x is equal to negative 2 sevenths, okay? So here, x could be 10, or x could be negative 2 sevenths. So let me erase everything. So I'll say that x could be equal to 10, or it could be negative 2 sevenths. Okay, that's going to be our answer. And again, you can check this if you want. Plug in a 10 for each occurrence of x, you'll see you get the same value on the left and the right. Plug in a negative 2 sevenths for each occurrence of x, you'll again see that you get the same value on the left and the right. So this guy is correct.